In the other modules, we have talked about SQL injection. Let's take another look, just a little closer look. So in our SQL injection, we have some objectives. You understand the concepts of SQL injection and the attacks and methodology, some of the tools and evasion techniques, and you understand some of the countermeasures, and you will learn to use detection tools. So we're going to talk about concepts, types of injection, methodology, tools, and countermeasures. Starting with concepts. The whole point of SQL injection, as I've said before, is you've got a web app talking to a database, which they do. You generally don't have a web app without a database. And the web app will use the structured query language, the SQL language, to make queries of the database. And a query can be to fetch information, to insert information, to update existing information, or to delete some existing information. So the thing about injection is if the web app does not validate its input, it could send all sorts of malicious commands in a form to the SQL server to be executed by the backend database. At the same time, if the SQL server doesn't have any validation mechanisms, it will accept these malicious commands. So we're trying to do SQL injection so we can have unauthorized access to a database and get information from it. It starts as a flaw in the web app, but the SQL server also has no built-in mechanism to validate the input. In other words, both the web app developer and the database administrator need to implement things that will stop SQL injection. So some of the threats. We can use it first and foremost to bypass authentication, to discover sensitive information, to compromise data integrity, and compromise availability of data, and possibly even compromise the host operating system because of remote code execution. So with SQL injection, we take advantage of one of these basic SQL functions, and we've talked about this already. Select, insert, delete, or update. We can test input elements, and not just form fields, but URL parameters and cookies, to see if we can input SQL data here. The very simplest injection method is to put in a single apostrophe or a single quote. We've talked about this before. This by itself will reveal errors in input handling, and if you see just the right kind of errors, you can go, this thing might be vulnerable to SQL injection. So we add an apostrophe to a username field in a login form. Since the apostrophe is not valid, it'll trigger the error. We can then leverage the always true values, and we've talked about these before. Always true is a or 1 equals 1 or something like that. We have certain web APIs that allow us to put multiple queries in one transaction, one call. And the union operator, as we've mentioned before, will allow us to combine results of 2 select statements and give us one output. And one of those select statements could be select star from customers. Of course, though, there might be some limits on this. You may have to provide some actual column names, and it works best when the 2 tables you're querying have the same number of columns. However, that's not a hard and fast rule. We've seen this already. A basic SQL injection example. Here's the illegal character, the apostrophe. It's not a backtick. So realize when you're looking at a keyboard, the apostrophe or single quote is on the same key as the double quote next to the enter key, the return key. The backtick, which goes the other way, is over by the tilde under the escape key in the far left. That's not what this is. So you have an invalid statement or a valid statement. This is the crux of the whole thing. What comes in front of this apostrophe could be anything. Blah just is anything. It could be even nothing. Here's an example where we are returning all accounts and their balances. Select the account number and the balance from a table. So these are columns. Account number and balance, these are column names. From a table called accounts, where the account owner ID equals 0 or 1 equals 1. Now, we don't know for a fact that there is an account ID with the number 0, but we're testing to see if it does exist. Because if 0 doesn't return anything, we'll try 1, then 2, then 3, then 4, and we'll keep on going up. Here are some examples. Some invalid input, hacker, or even just nothing, just this single quote. Or 1 equals 1. The dash dash means execute. So here's an example here. Something invalid, and then the semicolon, because see, SQL statements, you can run a whole bunch of them together just by separating them with semicolons. So I can say, do something, semicolon, do another thing, semicolon, do another thing, semicolon. Now, there are some things that you have to actually run as separate transactions. Like, you can't create a database and then insert data into the database as the same transaction. But just things like insert something, query something, you can do that. So this one is invalid. Okay, execute that, which it won't. Then insert into a table called user info, that's the table name, and put in these values. Now we've already done some queries to find out that there are 2 columns, name and password. And in regular SQL, if they exist in this order, name and password, and that's totally up to the construction of the table, then you put in a name and you put in a password. So what we're doing here is we're saying invalid, execute, then insert into the user info table a new person called hacker with a password called let me in. Finish that thing, tac tac run. Here's another SQL statement. Single quote, done. So invalid input, done. Create a database called hacker. So there's actually going to be a database called hacker. Done with that statement, run. Or, since this is Microsoft SQL, it has an extended stored procedure, and I know it's that because it has the name starts with XP underscore, and there are whole classes on SQL, folks. So we're not trying to teach you SQL per se. Some invalid input, fine. Then execute this stored procedure. You'll find it in the master database. The dot means the owner of the database. And then there's this procedure called XP underscore command shell. And now put in the DOS command in double quotes. Net user hacker, let me in /add. In other words, create a user called hacker with the password of let me in and add them. This is an operating system command, folks. It will not simply put a user called hacker let me in into a table called user info. It will create a Windows user called hacker with the password let me in. And then we're not done. Execute, find the XP command shell procedure. Now this command, net local group administrators /add hacker. If you can guess what that means, chocolate bar for you right now. Net local group is a command. Net is actually a command. Local group is a subcommand. We're saying in the administrator's local group, add the user hacker that we just created. So this is how dangerous and powerful SQL injection can be. Here's another example. I'm going to zoom in on this. Okay. Select star, meaning everything, from a table called users, where email equals, and notice we just have xxxx at. The xxx at, that means the password. And then, or excuse me, this is email. I'm sorry, thinking something else. This could be like joe@company.com, okay? So we're trying to find everything we can from a users table if there is an email address that matches this. Or, always true, limit 1, in other words, just give us 1, and then -- execute, and then this little apostrophe, and then this sort of closing square bracket, that's kind of like a comment, and password equals, and then do an MD5 conversion of 1, 2, 3, 4, give us the MD5 hash. This is a comment. SQL is going to ignore this, but when you run this, what it will actually give you is it'll say, since there's a true statement, I'm just getting whatever I can from the users table. The fact that the email has to match this, there's no such thing as xxx at xxx.xxx. That doesn't exist, but it doesn't matter because we have a true statement here and only give me one. And what it's going to do actually is it's going to produce ID number 1, the very first email, even though it doesn't follow the format, and not only that, the password in whatever hashed format it is. And I've only asked for 1. I said limit 1 here. So while this may seem a bit cryptic, the output is spectacular because now we can put this into a password cracker. And we know the email and the password cracker. And chances are excellent that the login is the email. Or we can do further investigation to find out what user account maps to this email address here. Now, you can also do SQL injection on the server side without using like a browser form. Microsoft's ASP.NET actually makes it very easy to do this. You can create vulnerable websites, or it will create vulnerable websites. So we can use this to exploit these types of servers using this technology with SQL injection without the help of a client front-end web app. So SQL Server, relational databases, MySQL, IBM DB2, they're all vulnerable to SQL injection attacks. And keep in mind that SQL injection is really websites that don't use secure coding as opposed to software that has vulnerabilities. So server-side attacks, we could do SQL queries in an HTTP post request. We could have SQL injection queries where we update a table, we add a record, we identify a table name, we delete a table. That would be destructive. So that's a primer on SQL injection concepts.